Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over section 10.3a of our Algebra 1 virtual text on radicals. We're going to be focusing on how to divide radicals. In this tutorial, we're going to be solving problems like simplifying 3 root 3 over root 5. Don't forget, we have 4 practice problems at the end of this presentation that we'd like you to try out in order to ensure that you've mastered the contents of this tutorial. Alright, before we get started with our practice examples, we're going to do a real quick review on our squares and square roots, okay? So let's do a real quick review on that. So let's start with our squares, okay? So what is 1 square? 1 square is 1 times 1, which is 1. 2 square is 2 times 2, which is 4. 3 square is 3 times 3, which is 9. 4 square is 4 times 4, which is 16. 5 square is 5 times 5, which is 25. 6 square is 6 times 6, which is 36. 7 square is 7 times 7, which is 49. 8 square is 8 times 8, which is 64. 9 square is 9 times 9, which is 81. 10 square is 10 times 10, which is 100. 11 square is 11 times 11, which is 121. And then the last one is 12 square, which is 12 times 12, and that is 144. So it's really important that you have these squares mastered. You want to have them memorized so it's easy for you to quickly carry out the division of radicals, okay? So if these are the squares, now let's take a look at the inverse. So if 1 square is 1, that follows that the square root of the square root of 1 is 1. Okay? If 2 square is 4, that follows that the square root of 4 is 2. Remember, square and square roots are inverse operations. If 3 square is 9, that follows that the square root of 9 is 3. If 4 square is 16, that follows that the square root of 16 is 4. If 5 square is 25, that follows that the square root of 25 is 5. If 6 square is 36, that follows that the square root of 36 is 6. Square root of 49 is 7. You see the pattern here? The square root of the perfect square 64 is 8. Square root of 81 is 9. The square root of 100 is 10. And this follows that the square root of 121 is 11, and the square root of 144 is 12. Okay, so you need to know your squares and your roots. Now let's go ahead and take a look at some examples. Alright, so the instructions are as follows. We are to simplify the following. Okay, so simplify. Let's take a look at the first question, number 1. Let's say you're to simplify the square root of 3 divided by the square root of 2. Alright, so how do you know that a radical is not simplified? Well, you are not to have a radical in the denominator position. Okay, so any number with a radical in the denominator position has to be simplified. What does that mean? It basically means that you need to get rid of that radical in the denominator position. So root 3 over root 2, this radical in the denominator, root 2, this radical operator needs to go. And then if we can get rid of it, then we've accomplished the simplification goal. So how do we get rid of root 2? Well, if we can create a perfect square in the denominator, the square root of a perfect square, then we can then use the inverse operation to simplify that as a root. Alright, so focus your attention on the denominator. We have root 2. What we're going to do is we're going to multiply by root 2 in the denominator and in the numerator. Root 2 over 2 is just 1. Alrighty, when you multiply by root 2 over 2 is the same thing as multiplying by 1. What happens when you multiply by 1 is a multiplicative identity, so nothing changes. Alright. Okay, so another thing to keep in mind is when you're simplifying radicals, always ask yourself if it is possible to reduce any components of what's given. Okay, so in this particular problem, root 3 and root 2 are the square root of numbers that cannot be reduced. They cannot be broken down any further, right? They're prime numbers, so you can basically take their square roots. Now, so let's go ahead and continue with the simplification. Now, when you multiply by root 2 on the top and the bottom, what you're doing is you're making the denominator irrational, okay? This process is called rationalization of the denominator. Let's write it down. So you're rationalizing the denominator. Rationalization. You're making something that is irrational. Root 2 is irrational. You're making it rational. What are we making it? Well, let's see. Root 3 times root 2 is going to be the square root. Now, when you're multiplying, you multiply the radicands. Okay, 3 times 2. And then in the denominator, when you're multiplying, you're going to multiply 2 times 2, which is the same thing as 2 square. Okay, let's go ahead and simplify. In the numerator, 3 times 2 is 6, so we have the square root of 6. Now notice what happens in the denominator. Since we have a square root of a square by design, guess what? The inverse operations cancel out. The square root and the square cancel out, and that's just 2. Another way to think about this is, what is the square root of 4? It's just 2. So we have this. Now, after rationalization, always check your numerator to see if it can be simplified. In the numerator, simplifying the numerator just involves taking out perfect squares, dividing out perfect square factors, and rooting them. All right, so let's see if we can simplify the numerator. So we're going to decompose 6 to see if there are any perfect squares hidden there or any factors that repeat. That's what a perfect square is. So 2 goes into 6 3 times. None of these factors repeat. That means that root 6 cannot be simplified any further. Your final answer is going to be root 6 over 2. Alrighty, let's take a look at another example, question number 2. Now for question 2, let's say we are to simplify 3 root 3 divided by root 5. You can see the difference here between number 2 and number 1. In number 2, the numerator has a coefficient. It's not just a radical. Okay? All right, so let's see how we can attack a problem like this. 3 root 3 over root 5. Now, root 3 cannot be simplified. It's prime. Root 5 cannot be simplified. So that's good. Now, we want to rationalize the denominator. All right, we need to get rid of this square root in the denominator. So we're just going to multiply by root 5 and root 5. The goal is to create the square root of a square in the denominator, as we did here, so that the square root and the squares divide out, and we are left with irrational. Okay, so what we're doing right now is we're rationalizing the denominator. We're making it rational. Okay, so let's do this. So this becomes 3 times the square root of, you multiply the radicands, 3 times 5. The same applies to the denominator. It's going to be the square root of 5 times 5, or we can just write it as 5 square. All right, and then this becomes 3 times the square root of 15 divided by the square root of 5 squared. These are inverses, so they take each other out, and you are left with 5. Okay, so now let's see. Can we simplify this radical right here? Well, I don't know. Let's say, so what we're going to do is we're going to see if there are any factors that repeat. Does this number have a perfect square as a factor? Let's factor out 3. 3 goes into 15 5 times. Oh, none of the factors repeat. 15 doesn't have a perfect square as a factor, hence it cannot be reduced. 3 and 5 have nothing in common, so the rationals cannot be reduced, and the irrational component cannot be reduced also. Ladies and gentlemen, this is the final answer for question number 2. Alrighty, let's take a look at question 3. So for question number 3, we're to simplify 2 root 2 divided by 3 root 10. Okay, so how do we simplify something like this? Now let's take a look at what we have. 2 root 2 and 3 root 10. Can anything be simplified in the given state? No, nothing can be simplified. Well, this radical here is prime. You can break it further. 10, well, let's see. Can 10 be reduced? I don't know. Root 10, break it down. 2 goes into 10, 5 times. So these two, none of them repeat. So root 10 cannot be simplified. All right, in 2 and 3, the rationals have nothing in common. So we can't carry out any simplification of what's given. So the next step now is to rationalize the denominator. Remember, you cannot have a square root in the denominator position. That will be an unsimplified form. So what we're going to do is we're going to rationalize the denominator. To accomplish that, we're going to multiply it by root 10 over root 10, which is the same thing as multiplying by 1, the multiplicative identity. And notice what happens here. We're going to have 2, okay, just bring the coefficient over root 2 times 10 divided by, and then we have 3 times root 10 times 10, and then we can write this as 2 times root 20 divided by 3 times root 10 times 10 is 10 squared, or 100. Now notice what happens in the denominator. You have the square root of a square. So what happens? Square root and squares are inverses, so they cancel each other out. And we have 2 root 20 over 3 times 10. All right, so the denominator is going to be 10. Now look at this 20 right here. Can it be reduced? Well, let's see. Is there a perfect square as a factor of 20? So we're going to decompose it completely. So root 20, take out a 2. 2 goes into 20, 10 times. And then since it's even 2 goes into 10, 5 times. Oh, check this out. A factor repeats. That is a square. 2 times 2 is a square. Hence, it can be reduced. It can be factored out. What is the square root of 2 times 2? The square root of 2 times 2 is 2. So this factor of 4, if we root it, it comes out of the square root as 2. Okay? And the 5 is by itself. It's not a square, so it stays behind. The simplified form of root 20 is the 2, which comes as a result of taking the square root of the factor 4, and then roots the 5, which stays behind. Okay, so let's go ahead and insert that simplified form in our problem. So we have 2 times 2 root 5. 2 root 5 is the simplified form of root 20 divided by 30. Bam, like that. Now, how do we multiply 2 and 2 root 5? Well, you just multiply the rational parts, the coefficients with each other. 2 times 2, which is 4, and bring down the radical component, root 5. Okay, and then we have that divided by 30. Almost there. Now look at the rationals, 4 and 30. Do they have anything in common? Absolutely, they're both even numbers, so we can divide those by 2. Okay, divide by 2, divide by 2. And that yields 4 divided by 2 is 2. 2 root 5 over 30 divided by 2, 15. Ladies and gentlemen, the answer to question number 3 is 2 root 5 over 15. One more example. We're going to do one more example, and then we will give you an opportunity to do some practice problems to demonstrate that you've mastered the art of dividing radicals. All right, now let's say we have something like this. This is an interesting problem. Let's say we want to divide the square root of 14, the square root of 16 by the square root of 12. Okay, let's look at the numerator first. What do you notice about the numerator? 16, ladies and gentlemen, is a perfect square. So what is the square root of a perfect square? The square root of 16 is 4 because 4 squared is 16. Bam. So this is a situation where you can actually simplify what's originally given. Now let's direct our attention to 12, root 12. Can this be broken down? Is there a perfect square as a factor of 12? Or does 12 have any factors that repeat when it's decomposed completely as a product of primes? Well, let's see. The first prime that goes into 12 is 2. 2 goes into 12 6 times. 6 is even. 2 goes into 6 3 times. Ladies and gentlemen, we have a repetition. 2 times 2, which is 4, is a factor of 12. Hence, root 12 can be simplified. We factor out that 4 and we take the square root. The square root of 4, or 2 times 2, is 2. All right, so this pair comes out as 2 because that's what the square root of a square does. And 3 stands alone without a partner, so it stays behind. And the simplified form of root 12 is 2 root 3. So let's insert that down here. So in this particular problem, we see how it's interesting. We have a situation where we could actually simplify the original problem before rationalization. And then we can even carry another further simplification here. If you notice, 4 and 2 have something in common, namely 2, right? So we can divide the top and the bottom by 2. And that will give us a further simplified state, which is 2 divided by 1 root 3, which is just root 3. All right, now let's go ahead and get rid of the radical in the denominator, okay, because you can have a radical in the denominator position. So we're going to multiply by a variation of 1, namely root 3 over root 3. The goal is to create a root of a perfect square in the denominator. Alrighty, so if we do that, we're going to have 2 root 3 divided by the square root of 3 times 3, which is equal to 2 root 3 divided by, you can write it as root 9 or root 3 square, is exactly the same thing. But I'm writing it as a square so you can see the interaction between the square root operation and the square. They take each other out. And we have our final answer, which is 2 root 3 over 3 as a simplified form of root 16 over root 12. All right, ladies and gentlemen, it's your turn to do some practice problems. All right, so we'd like you to try out the following practice problems. So what you're going to do is go ahead and pause this video presentation and simplify. The instructions are the same as before. Simplify these 4 problems. When you're done, click on the playback button, and then we're going to reveal what the correct answers to these 4 practice problems are. Welcome back. Hopefully you had a chance to try out the problems. Let's take a look at what the answers are. Question number 1, the answer is root 10 over 15 in a simplified state. Number 2, the answer is 3 root 10 over 10. For number 3, the answer is 2 root 15 over 5. And number 4, final answer is root 15 over 2. Alrighty, ladies and gentlemen, how well did you do in these 4 practice problems? Let us know what your score is in the comment section below. And if there are any of these problems that you need clarification on, that you had issues with, let us know what it is in the comment section below, and we'll be more than glad to support you. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your preparation for Algebra 1, do give us a thumbs up or a like. Your positive feedback is very valuable to us. Do not forget to subscribe to our channel for updates to other presentations such as this. Our website, Mathgotserved.com, has tons of support resources to help you in your learning of, of mathematics. And if you have any special requests or questions, just put it in the comment section below and we'll be more than glad to support you. Thanks again for watching and have a wonderful day. Goodbye.